Welcome back. Thanks for joining me today in the shrine on the altar. A little bit of mess, so I need to move all this nonsense out of here first and introduce a containment vessel. And we're gonna need this because of reasons. We're gonna be looking into this pump. This is an RV pump. You can typically find them tucked away in the RVs. This can be in the back, in the front. It can be on under the counter. And what this is called, it's a on-demand pump. And the way it works is it's got an inlet side and outlet side, as you can see. So it shows the flow here. Okay, this is the inlet, this is the outlet. It hooks up to 12 volts, and once you energize it, it will create pressure. And then once it creates enough pressure, there's a switch here inside this box, and that switch is going to turn the pump off. So next time someone opens a faucet, or there's a low, pressure in the line, then the pump is going to kick in and it will supply water. So I had this pump in my RV, and what happened is I did a poor job of winterizing it. We're going to talk about that a little bit later. And next year the pump didn't work, so I bought a new pump, installed that, and then we got this one, so we can go and disassemble it and see how it's built. So first of all, it's made by SureFlow. You can see the manufacturer here. Here's a nameplate. It's got a serial number 226547, model number. It's a 12 volt, 7.5 amps max. That typically kicks in when the motor turns on. This a flow rate 3 gallons per minute, or 11.3 liters per minute. It needs a 10 amp fuse circuit. The shutoff pressure is 55 psi, a 3.7 bar. So these are all the vital characteristics of the pump, and this was made in Mexico. So what we're going to do first is take it apart and see what's inside. And when I took it apart initially to see what's wrong with it, one of these bolts got stripped, so I just replaced it with a longer bolt and did some fixing to it. And you can see I didn't have exactly the same size fastener that I needed, so I just improvised a fastener. Now, one thing I want to mention is that you can see I turned the pump this way and I turned the pump that way, and a couple drops of water will come out. But essentially I introduced the containment vessel here because I'm anticipating that there will be extra water inside. Okay, so you can see what just happened. When I popped this open, some more water flowed out. So why this is important? Well, it's important because if you don't properly winterize the camper, then this excess water that is trapped inside can freeze, and it can just create all kind of problems inside the pump itself. So I'm going to remove this wire. So there are two wires here, you can see on this side, and it just goes to this switch. And essentially what this switch does, it turns the motor on and off. Also, you can see right here there's a hex screw, okay, a worm screw, and you can use a small hex wrench and adjust the screw in and out. So that will essentially figure out where that turn on and turn off point is for this switch. So what happened in my case, the water that got trapped inside here within this region under the diaphragm pressed on this plunger and basically broke the inside of the plunger. So there is a compartment inside here. Okay, so you can see this is just a plastic housing piece and there's a diaphragm. So this is supposed to seal off the internal cavity where the water flows from this region where the actual switching action is occurring. So there's a spring here, and this spring is gonna preload this plunger. And this plunger basically, when the pressure on this side rises, this plunger is gonna move to the right against the spring, compress the spring, and then the end of the plunger is gonna depress, you know, it goes in there and it's gonna actuate the switch on and off. So this is an interesting way, this is interesting the way it's done. So I'm assuming that this cavity here inside, it's got fluid, it's got water, and then this acts as a piston. So what we have here is high pressure acting on this one, and then it creates even higher pressure inside here. Okay, and when that happens, that's gonna actuate this rubber plunger and create a pressure on this side of the rubber plunger, and the plunger or this diaphragm is gonna move and it's gonna actuate this switch. So here you can hear when I'm depressing the switch, okay, it actuates the switch inside, so it disconnects a circuit, connects or disconnects a circuit. We can double check that. We have a meter here. So as you can see, the meter is set to continuity, and I'm depressing the switch. If I'm letting the switch go, then it closes the circuit. So if the pressure increases on this side, that will depress the switch and basically open the circuit and shut the motor off. So this could be one of the failure modes on your RV. Again, if you did not winterize it, there's a good chance that something inside here is broken, and you don't need to take apart the entire pump for this reason. You can just remove these 3 bolts here on the top and then look inside and check if there's a failure on any of these parts. So in my case, what happened is there's this plunger, and this part of the plunger was broken off, and I can assume that, you know, there's water all around this part, and when it will freeze in the winter, then it can just break those components. It's that simple. So this is basically the switch side. I've seen multiple different pumps like this, and they basically all work in the same way. Again, these are called on demand because when there's a pressure drop on the outlet side, then that will automatically kick the motor in and it will supply the water. And one of the interesting things about this type of a pump is that it doesn't need priming. So that's the motor part here. Okay, I'm just going to set that aside, and then this is the actual pump part, and you can see some debris inside. So this probably came in from the line, so that might have been in a tank, but some kind of shmoo got inside. So we're going to look into this in a moment. What happens here is this is basically the motor part, that what drives the pump. You can see it's got a D shaft, so there's a flat on the shaft that engages this central shaft, and when this shaft is spinning, it moves something inside. So see what happened? When I move that, when I open that up, there's more water inside. So you can see it has 4 chambers. So, okay. And then each chamber has multiple valves. So you can see the valves here. So there's a big valve on each corner, and there's a small valve in the centers here. And what you can see is that this valve, okay, this outside valve, opens this way. So when there's suction, where a low pressure is generated in this area, then this valve is going to pop open. So I need something sharp, but you can see that there are these windows, these little windows. Okay, so I can put this piece here, and through the window I can depress the valve. This is just a small rubber piece, and you can see that that actuates the valve. So if inside this chamber there's a low pressure, then this valve is going to pop open and it will let the fluid in. So the fluid comes in and fills up this chamber. Okay, so when there's high pressure in this chamber, then this second valve, which is in the center, it opens and it will let the pressure come through into this channel. And the way this is done, you can see there's a central seal in the center here, and when this guy sits there, then this outside area is the inlet, so that's where the water is coming in, and then this center section is the outlet. And we can verify that easily. You can see that there's the arrow points in this direction, so this is the outlet and then this is the inlet. So again, the water comes in through this port, it fills up this chamber, this outer chamber, and then it comes into one of these 4 chambers, and then these valves, the in and out valves, are regulating when the water is coming in and out, and essentially it fills up this cavity, okay, and then through this cavity, through the outlet, it will leave the pump body. So this is where the pumping action happens, and what you can see here is I'm turning this center piece, and what it does, it creates a cam action, okay, and the way it's done, you can see that when I'm turning this, the shaft, the angle of the shaft, okay, this angle of the shaft is changing, so that shaft is wobbling like that. So this is placed on the motor, so when the motor is turning, then it's gonna move these sections in and out, okay, continuously. And what it does, that basically creates the pumping action. So you can see this housing here, this one is stationary, and then this one, this housing can move and wobble, but it's pretty much captured. So when the shaft is turning, then it's moving in and out like that, okay, so something like that. I don't see a reason to take it further apart. You can pretty much see that that's how the pumping action happens. You can actually put that right there. So when I'm turning this just running freely, and you can see that it's doing that wobbly motion. So you can see that it's not concentric with this bearing outside diameter, but it's rather wobbling. Now, if I keep this shaft steady in the center, because the bearings in a motor will hold it centered, then this outside piece is going to start wobbling like that. And when I do that, you can hear that sound. You can actually hear the pump running. I hope that it comes through the microphone. I'm going to clean it up a little bit, just get rid of the water, and then we can go and look into the motor part. So first of all, it's mounted on this rickety rubber foot, and I've seen these pumps being mounted this way or to the side or upside down like this. It doesn't matter at this point, because the way the pump is built, it is gonna prime itself. So it doesn't matter how it stands, it will prime itself. Now the other problem is that the water is not gonna get out, because these valves here are most of the time closed when there's no excess pressure opening and closing them. So the problem with this pump is really that it will trap the water. So you will need to make sure that you get that water out if you want to winterize the RV. I've heard some people applying compressed air. What we're going to do next is do a couple tests, and we're going to look how that compressed air is getting rid of the water inside. I have doubts about it, but we'll see. Some of the RV places will run antifreeze, and there's a special antifreeze you can buy in a big box stores to put into the RV. Do not put regular antifreeze into the RV system, because it's poisonous. So there is special RV antifreeze formulations that one can buy in a big RV stores, and use that if you want to winterize your RV at home. As far as sanitizing go, just follow the recommendations in the instruction manual. You can see that there is a lot of different type of materials here. So there's ABS plastic, I'm guessing. That's some kind of ABS plastic. There's rubber, there's a different rubber compound, there's aluminum. So if you are using not the proper sanitizing fluid, that can definitely hurt the pump. One more thing I saw here, so you can see there's an extra cavity with an adjustment screw. So what this does, it's gonna release the pressure. So you can see inside there's a plunger, and it connects the high pressure and the low pressure sections. I'm sorry, this is the high pressure section and this is the low pressure section. So this is the inlet, and then this is the outlet. And so when the pressure is increasing to a high level inside the pump on the output side, then this valve is going to pop open and let some of the pressure out into the inlet side. Let's look inside the motor. These are just regular through bolts. That's the cheapest way to put these DC motors together. Here's the front end. Here's the back end. There are the two brushes. There's some washers here. And let's pull this out. So this is the housing. And you can see the housing has two ferrite magnets. So it's a DC motor, it's a permanent magnet DC motor. That's one of the cheapest ways to do it. It's just an extruded housing. It's got these threads cut into the housing. There are two bolts holding the feet inside the housing. And you can see there's two permanent magnets. So these permanent magnets are, you know, they've been making them for 150 years. They are dirt cheap. Some of the engineers call them arcuates. And right here you can see the green residue, so that's just from the glue. What they do is they permanently glue these magnets into the housing. So it's dirt simple. You don't need to wind a coil, you don't need to put any more copper into it. This is a real cheap motor. Now, some of these pumps are being sold online. If you look up eBay, you know, 65, 75 bucks. I know because I work in the industry that putting all this together would probably cost in a range of, I'd say, $13 to $15. We make similar size starter motors for automotive industry, and I know what their cost is, and they actually have more complex parts. There's more money put into them. So here's the rotor or armature in this case. So we got DC power coming in, and then this armature is spinning, and then this is the commutator part. The commutator is touching two brushes, and then when that happens, you know, as the armature rotates, the brushes are touching the commutator on both sides, and so different circuits are being turned on here. So despite that there's DC power going in, there's an AC power happening inside the armature. And you can see it's just a wound armature from some thin wire, looks like half a millimeter. It's not really high speed, so there's no bending on the ends. They didn't think that you know, these wires will fly apart. There's probably some kind of varnish impregnation on the wires to hold it together. And then on the commutator side here, you can see that it's staked in. The wires are staked in. So the way they do it is there's these little tabs on the commutator, and they're sticking out in a radial fashion, and they bring in the wire, and then they will bend this in, and maybe they will weld it. The inside of the commutator is made out of plastic, so these individual bars are not connected to each other. So the two neighboring bars are not connected to each other. There's looks like a shielded bearing on the drive side. There's a large shielded bearing. It says China VNC 6203, so that's probably a skateboard bearing. There's some plastic bushing here on this side. Okay, you can see the plastic bushing, and then it goes through some kind of powder metal hub. It looks like a powder metal hub to bring up the size of the shaft to the inside diameter of the bearing. So it's pretty simple. These are the brushes. You can see on the commutator side there's a bushing here, so this is just an impregnated bushing. It's made for life. It doesn't really need a replacement. It's just some kind of copper bronze mixture that's really porous on the inside, and it's sintered, and what they do is they soak it in oil, so that oil is gonna get trapped inside this, and it provides lubrication for the life of the machine. So these are the brush holders. They are made out of plastic. The back cover is steel. It's just a deep drawn steel piece. So this is just an injection molded plastic housing. There is no marking on it as far as material, what might be the material. And you can see these brushes here are in a brush holder, and they preloaded by these springs. So the springs provide a constant tension on the brushes, and so brushes have some kind of orange brown color, so I'm assuming they have a lot of copper in them, because the way this pump works is it starts a lot of time. So every time you start the motor, it will draw a lot of current. The DC motors are drawing the highest current at lock torque, or lock torque is basically when the shaft is stationary. So every time you start this up, it's going to draw current. And one more interesting thing here, you can see there's a pre-packaged item in this area, and you can see two brushes or two wires coming in. So there's a black wire and there's a red wire, and then the red wire is terminated in this device, and then the brush wire comes out from the device. So what might this be? So this item is a switch. In the industry we know it as a clickstone switch. So what it does, it just prevents the whole thing from going up in fire. So if there's an excess heat or the shaft is locked and you just keep running current, then obviously everything will heat up inside, and this can go into a uncontrolled thermal event. That's what at least the industry calls it. So when this thermal event happens, it can just melt the plastic here and just go up in flames. So that's what this switch is supposed to prevent. If the temperature reaches a specific point, then this will just turn the whole thing off. And so typically the brush holders are the hottest areas within the motor, so that's why these switches are always there. That can be also one of the failure modes. So if you energize the motor without turning to the switch, so you disconnect the motor from the switch and you just energize these two wires on the motor, and the motor is not spinning, considering that there's no fluid inside, or the shaft is free to turn, then most likely you have an open circuit. And then in this case, you can try replacing this switch and see if it fixes the problem. And if you are real brave, you can just disconnect the switch and hook up those two wires. But you got to make sure that you have a good fuse in the system to prevent any further damage. So next thing I'm gonna do is put it together, and then we're gonna do some tests. Okay, so you can see that I added the motor and put this pumping element on the motor. So when I turn the shaft, you can see the wobbling motion. So that's how the pump works. Basically this plunger moves in and out, and then these valves are opening and closing. So here's the motor part assembled to the pump, and you can hear when I'm turning the motor, it actually does the pumping motion. So one of the reasons they use these motors is because it's self-priming the system. So you couldn't do this, for example, with a centrifugal pump unless you have like a water reservoir above the pump that supplies water, because that centrifugal pump is just going to churn the air inside, and it doesn't have enough momentum to pick up the water and prime it. But this motor, this pump, can prime itself. When you're putting the motor housing on, you can see that it's keyed. So there's one notch here and then one notch here. Okay, and there's a cast tab on this side, so you can put it either this way or you can put it that way. Okay, and then you gotta make sure it doesn't pinch your finger. Now when putting the commutator on, it's really important to put it in a right position, because if you clock the commutator relative to the poles here, that will change the timing of the motor. So take good care of putting this tab right there into this notch when you're putting it together. So this can be problematic when you're installing the brushes, so that can be a tedious job. So here's how you do it. Try to remove this back cover. Okay, it just slips off easily. And then I push the brushes back against the spring, and I just used a pin, and that pin is holding the brush in place. So you can see there's a pin, there's an Allen wrench on this side. Doesn't matter what you use, as far as it fits into this slot, it will retain the brush. So once you have that done, then it takes a little adjustment like so, and now you can install the brush holder onto the motor like that. It looks like I need to change the motor. So there's 2 notches on this side. So you can see I installed the brush holder. I can pull the pins out and then that will seat the brushes properly. And now the next item is to put back this back cover. Just make sure everything goes back to its proper position, like so. And then this back cover can be installed, and then the through bolts can go in. So now the motor part is assembled. We can put back the plunger. Okay, it goes in like that. Here's the spring. And there's the diaphragm. So this goes in one way only. You can see how the bolts are clocked relative to each other. So it's seated like that. And now the switch can be installed. So I got the motor set up with this water container here, and as you can see there's no water in the lines, so the pump is empty. There's no water in the pump. On the inlet side, on the outlet side, everything is empty. So what I'm gonna do next is I'm gonna turn the motor on and we'll see what happens. Okay. So what you can see is the motor automatically primed itself. All the lines were empty, and nonetheless the motor and the pump primed itself. And now the water is running. So if I close the valve here, you can see the pressure is going to go up. It will increase. And right now we're running about 40 psi on the outlet side, and that will get this switch open, and that will shut the motor off. Now, if you have this system in your RV and there's a leaky faucet, let's see what happens. So I'm going to go and slowly open the faucet. Okay, so I'm opening the faucet. And as you can see, there's tons of vibration. Now that's due to the fact that this valve, this faucet, has a plunger that closes the channel here. And so when a little bit of water starts to flow, then the pressure drops, the pump kicks in, that increases the pressure, and then it moves that diaphragm in and out. And so that's why there's a vibration. But let's say there's a leaky faucet. So you can see that faucet is not completely closed. What happens, it will turn the motor on and off in regular intervals. So you can see water is dripping there and the motor keeps turning on and off. So what happens here is when the pressure drops, this switch actuates, turns the motor on, the motor is going to turn, it creates the pressure and it shuts the switch off. Now every time the motor turns on, it will draw current from the battery. So if you are not on the city power, the RV is not connected, let's say to 110 volts, then it's using battery power from your battery, and you might not even know about it. It's just a small leaky faucet, but overnight or over time it can completely drain the battery. So you always need to make sure that the faucets either in the kitchen of the RV or in the bathroom are always completely shut off, especially if you are not on the city power. So right now the motor is completely primed, you can see both the inlet and the outlet has water inside. So what I'm gonna do now is shut the motor off, and I'm gonna go and drain the water completely from the system. So I got the water completely drained from the inlet and outlet. Okay, so if the motor is sitting this way and there's an open valve somewhere down here, it's going to drain this side, but you still can have drain on this side, but you can still have water up here. Okay, so you're not going to take this out of the RV to winterize it, obviously, so there can be some water trapped in the system. But what we're going to do is we're going to hook this up to a compressor and blow this out, and then we're going to take it apart and see if there's any water remaining inside. As you can hear, we got compressed air. It's pumped up to 80 psi. I got the inlet connector installed. It's flowing that way, so we're going to go and just pump it with air. Well, you saw what I saw. Looks like all the water came out of it. So let's pop it open and see what we can find inside. I'm just gonna go and open this side and see if there's any more water inside. Okay, here comes nothing. So that's dry. You can see this is dry. I'd say there's a teaspoonful of water inside, which is not much. So here's the plunger part that turns it on and off. There seems to be no water in this area either. So it looks like the 80 psi compressed air did a great job of evacuating all the water from the system. So that would be a wrap for today. I hope you learned something. Again, if you have an RV with a self-priming pump, make sure that you winterize it properly. Either use compressed air or use a designated antifreeze and winterize it that way. Hope you guys learned something. If you like the video, please give me a thumbs up, and if you like the channel, please don't forget to subscribe. Thank you. See you next time. Bye.